Here we go, alright? So, first thing you want to do is you're looking to prove any letters of your choosing really, but generally speaking we'll be going for A over sine A equals B over sine B. Is that what we're looking to do? Now, what you have to learn off by heart? Well, the first thing you got to learn off by heart is that you're going to do a diagram. Okay? And in your diagram is actually on the same page as the sine rule itself in your notes. So if you go to your notes and you find the sine rule, you'll be looking at a triangle that you need basically, alright? Huh? Page 16, alright? Yeah, you can use the diagram on page 16, no bother. Diagram on page 16 is perfect, alright? If you don't want to learn anything else. Now all you do is go, you're capital A. So who automatically small a? Yeah. You're capital B. So you're automatically. Now, one thing you need to have learned off by heart. The diagram you're going to take from page 16. Your first bit of learning is two right-angled triangles. That's the first piece of information you're going to learn off. And what that means is that you're going to construct a line straight down. Okay? And so you say, and that's, you can call that C and C and C as well if you want. And the vertices are also called A, B, and C. Is that alright? Now, here's what we're going to do. We're going to use right-angled rules here, alright? You have to use the following. You have to use sine A and you have to use sine B. That's a no-brainer, isn't it? Why? Because they're in the actual answer, aren't they? So now we're going to use sine A and sine B. Now, pick a letter. You don't have to learn the letter off by heart. Pick a letter to represent this green line here. It can be any letter of your choosing. It doesn't have to be H. For argument's sake, I'll keep it as H, the height of the triangle, okay? Now, what is sine A using the right angle triangle on the right? Opposite over hypotenuse, which is? Okay. Using the triangle on the right, what's sine B? Huh? H over A. Opposite over hypotenuse. Now here's what you're going to do next. What line is in both triangles? So if you isolate H, you can explain both triangles in terms of each other, okay? So what we're going to do is we're going to isolate H on its own. So what's H on its own here? And in turn that will equal? A sine B. And you're sort of looking going, okay, can I? Well, you have two ways of doing it. See the sine A? Multiplication on the left, which will make it what on the right? See the sine B? Multiplication on the right, which will make it what on the left? Division. And there you go. There's your sine rule done. Is that alright? It's not too hard. Now we're going to do the obtuse case. If it says prove the sine rule in an obtuse triangle, and so you still want to prove that A over sine A is B over. Now you will put angle B. You mark off angle B as obtuse. Okay, so you will have that learned off. Design the triangle any way you want, but make sure B is obtuse. Is that alright? Just that one of the angles is over 180 degrees, or sorry, over 90 degrees, alright? So we do the normal. We go, your angle A, angle B is here, and you just create your triangle as normal. A, B, that'll make you small b, that'll make you small a, that'll make you c, that'll make you small c. This is vertex A, this is vertex B, and this is vertex C. Done. Alright. Now, in this case, the problem is the right angle triangle is outside. See the way it's outside? You can't really do that because it's not a full length, is it? So you're going to have to make your right angle triangle on the outside of the current triangle, which is a bit of a problem, alright? So you're going to make it out here. So that's the one thing you have to say. In the obtuse triangle case, the right angle triangle is on the outside. in both cases we do create two right angle triangles though, don't we? Does everybody see the two right angle triangles we created? It's the big one and the small one on the right. So this is one of your right angle triangles, it's the whole thing, and your second right angle triangle is the small one. And you're going to use both of them separately. You have to use the two of them. Okay. What line is common in both triangles? This one here, isn't it? That's the one that's common in both triangles, and that's the one that's going to link the information together. Okay, let's start off with the large triangle. What's sine A equal to? Huh? H over B. I haven't got access to sine B, do I? But what do I have access to? Sine 180. What's sine 180 minus B? H over A. Now, it's your choice how you want to get rid of this, okay? So, because it's in the second quadrant, any angle you want. So, I'll give you an example. Sine 60 is actually the same value as sine 120 when you put them both in the calculator. Can anybody tell me what angle sine 40 would be the same as? Sine 140. Does everybody get what you're doing? Would anybody tell me what angle sine 85 is the same as? Sine 95. Whatever the angle you're given, just take it away from 180 and that's exactly what it's the same as. Alright? Because remember ASTC, sine is positive in the first and second quadrants. So that's why you're allowed to do that, okay? So, what I'm going to ask you now is, what's sine B the same as? Exactly. So sine B equals sine 180 minus B because it's in the second quadrant. Okay? Now, what can I write down then? Sine B equals H over A. Now we're going to isolate H, aren't we, like we did last time? And what's H equal to? B sine A. And it also equals? And then what do I do with sine A? A over sine A equals? And that there is your sine rule.